Assalamualaikum and good morning to Madam Marliana. Hi, my name is Amirul Haziq bin Sezali. I'm from DEM 3A and my matrix number is 23 DEM 20F 1032, and today I want to talk about Newton's first law, the law of inertia. Okay, the first of all, I want to talk about what is Newton first law. All right. The first law states that an object at rest will stay at rest, and an object in motion unless acted on by a net force. Mathematically, this is equivalent to saying that if the net force on an object is zero, then the velocity of the object is constant. Okay, and other than that, I want to talk about what are Newton's laws of motion important. And first of all, Newton's law of motion is important because they are the foundation of classical mechanics, one of the main branches of physics. Mechanics is the study of how objects move. Okay, next is I want to do a simple experiment of Newton's first law that is coin in a cup. Alright, for this we need uh, we need a glass of water, and we need a coin, and the last one we need a card. So this card I just use my the license card. Alright, how does it works? Alright, I want to prove that how does this experiments works for the Newton first law. Okay, see, right? First of all, we put this card on a glass of water, and next is we put this coin on this card, right? And we pull this card fastly, okay, just like this. And at this moment, all right, at this moment we saw that an object in motion acted on by a net force. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad F1027 bin Muhammad Arnim. Saya dari kelas DEM 3A. Nombor matrik saya ialah 23 DEM 20F1034. Hari ini saya akan membuat eksperimen mengenai Newton second law. Hukum Newton second law berkaitan dengan tingkah laku objek yang mana semua kekuatan yang ada tidak seimbang, dan Newton second law menyatakan bahawa pecutan sesuatu objek bergantung kepada dua pemboleh ubah yang bertindak pada objek dan jisim objek. Sebagai contoh, lihat eksperimen ini. Itu saja daripada saya. Sekian, terima kasih.
Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Hari ini saya Muhammad ZAQWAN MUKRY bin Karam Zaman daripada kelas DEM 3A nombor matriks 23 DEM 20 F1027 ingin bercakap tentang Newton's third law. So, pertama sekali, Newton's law of motion. In classical mechanics, Newton's law of motion are three laws that describe the relationship between the motion of an object and the force acting on it. The first law states that an object either remains at rest or continue to move at constant velocity unless it is acted upon by an external force. The second law states that the rate of change of momentum of an object is directly proportional to the force applied for an object with constant mass, and then the net force of an object is equal to the mass of that object multiplied by the acceleration. The third law states that when one object exerts a force from a second object, the second object exerts a force that is equal in magnitude and opposite in direction of the first object. The three laws of motion were first compiled by Isaac Newton in his Philosopher's Naturalistic Principia Mathematicus, the first published in 1687. Newton used them to explain and investigate the motion of many physical objects and systems, which laid the foundation of Newtonian mechanics. More about Newton's third law is Newton's third law is the law that the two forces in Newton are the same type. Example, if the road exerts a forward frictional force on an accelerating car tires, then it is also a frictional force that Newton's third law predicts for the tire pushing backward on the road. From a conceptual standpoint, Newton's third law is seen when a person walks. They push against the floor and the floor pushes against the person. Similarly, the tires of car push against the road while the road push back on the tires. Newton used the third law to drive the law of conservation of momentum from a deeper perspective. However, conservation of momentum is the more fundamental idea derived by via Noether's theorem and from Galilean invariance, and hold in case where Newton's third law, force field, as well as particles carry momentum, and in quantum mechanics. The history of Newton's law is come from the ancient Greek philosopher Aristotle had the view that all objects have natural place in the universe, that heavy objects such as rock wanted to be rest on the earth, and the light object like smoke wanted to be the rest in the sky, and the stars wanted to remain in the heaven. He thought that a body was in its natural state when it was at rest, and for the body to move in a straight line at a constant speed, an external agent was needed to continually propel it, otherwise it will stop moving. Galileo Galilei, however, realized that a force is necessary to change the velocity of a body, like acceleration, but no force is needed to maintain its velocity. In other words, Galileo stated that in the absence of a force, a moving object will continue moving. The insight was refined by Newton, who made into his first law, also known as the law of inertia. No force means no acceleration, and hence the body will maintain its velocity. As Newton's first law is a reassessment of the law of inertia, which Galileo had already subscribed, Newton apparently gave credit to Galileo. The importance and the range of validity. Newton's law were verified by experiment and observation for over 200 years, and they are excellent approximation at the scale and speeds everyday life. Newton's law of motion, together with his law of universe gravitation and the mathematical technique of calculus, provide for the first time an undefined quantitative explanation of wide range physical phenomena. For example, the third volume of the Principia, Newton showed that his law of motion combined with the law of universal gravitation explained Kepler's law of planetary motion. Newton's law are applied, which are idealized as single point mass in the sense of the size and shape of the body are neglected to focus on its motion more easily. This can be done when the line of action of the resultant of all external force act through the center of the mass of the body. In that way, even a planet can be idealized as a particle for analysis its orbital moon around a star. In their original form, Newton's law of motion are not adequate to the characteristic of motion of rigid body and deformable bodies. Leonhard Euler in 1750 introduced a generalization of Newton's law of motion for rigid bodies called Euler laws of motion, later applied as well for deformation continuum. If a body is represented as an assemblage of discrete particles, each governed by Newton's law of motion, then Euler law can be the law. However, be taken as axiom describing the law for the motion extended body, independently for any particular structure. That's only today for me, and thank you.